All right, Chapter 3, Section 2. In Chapter 3, Section 1, we looked at solving systems using graphs and tables. Here we're going to look at solving systems algebraically. So same kind of stuff, just different way to solve. All right. You learned this in Algebra 1, so this video is going to be brief. One of the ways that we learned in Algebra 1 was substitution. To do substitution, what you have to do is you have to take one of the equations, set it equal to one variable. So just solve for one variable. So in this one, we're going to solve for y just by subtracting 2x from both sides. Then we're going to take this negative 2x plus 10 and substitute it, hence the name, in for the y in the other equation. Solve for x, plug that x into either equation, and you get the y. It's really just as simple as that. Substitute in and solve. So let's take a look at this one. So on this equation, on this system, you have to pick which equation would be the easiest to substitute into, or the easiest to solve for, excuse me. So here we have one lonesome x all by itself. So let's solve that one for x. So we just subtract 3y from both sides, and I have 3y, negative 3y plus 5. Then I'm going to substitute this into the other equation for the x value. Okay, so I'm going to take this, and I'm going to plug it into that x right there. So now let's rewrite this. When we substitute, we want to substitute into parentheses. So this is negative 2 times. This is negative 2 times x, and we're saying that x equals that, so that's why we're allowed to substitute it. Negative 3y plus 5. Got to watch out for sign error. Got to watch out for things like not copying it down correctly. Other than that, this is just some basic algebra solving equations now. This is 6y minus 10 minus 4y equals negative 5. Over here on this side, we end up with 2y, and on that side we have 5. So y equals 2.5 or 5 halves, or however you want to think of that. Then what we do from here is we substitute this into either y. Now the top equation was just simpler, so I'm always going to take the lazy way out, and I'm going to substitute in there. X plus 3 times 2.5 equals 5. So x equals 3 times 2.5 is 7.5. Sorry, that's not an equals. X plus, equals 5. Subtract it from both sides, and I get x equals negative 2.5. So the solution is negative 2.5, 2.5, because the solution here is a point. So that's the answer. All right? Take a look at problem number 2. Using substitution to solve a word problem, we have to come up with the problem, and then we're going to substitute. Really simple stuff here. It's a music store, and it's basically saying, what is the cost of each lesson and a one-time fee for materials? If 6 lessons are that, and 12 lessons are that, we want to know what's the cost of one lesson and what's the one-time fee. So 6 times the cost of one lesson plus the one-time fee equals 300. We don't know either of those, so that's where we use our variables. So 6 times c plus f equals 300. 12 times c plus f equals 480. We have those two equations, right here and right here, and then we just substitute. We solved for f, so we solved for the one-time fee, and we got 30. We plug that 30 back in, and we get 120. And so those are our answers. You can check it by substituting anything in and making sure that they both equal each other. This is really not that complicated, and again, it's all review. So let's take a look here. An online music company offers 15 downloads for $19.75 or 40 downloads for $43.50. Each price includes the same one-time registration fee. What is the cost of each download? So the easy way to do that is just to, using variables that make sense are important. So if we said 15 downloads plus the registration fee, so we could go R or F, I'll go R, equals 19.75. And then the other equation is 40D plus the same registration fee equals 43.50. There's the setup. You go ahead and pause the video right here, solve that problem, get what's the download fee and what's the registration fee. Go ahead and solve that one algebraically using substitution on your own. Pause the video now. All right, you've unpaused. Hopefully for your answers, you got, for download, the downloads cost 95 cents. And the registration fee was $5.50. That's it. Okay? If you didn't get that, try the problem again. If you still don't get it, make note of that, and we'll go over that one in class. Let's take a look at the next page. We also learned how to solve by elimination. Okay? Elimination. This is where we had we had to line the two equations up perfectly. So x's with x's, y's with y's, constant with constants, and this is also really important, the equal signs had to be lined up. Then if one of them was the opposite of the other, or if we could manipulate them so that one of them was the opposite of the other, we literally just add straight down, solve for the one that's left, plug it back in, solve for the other one. Simple as that. So let's take a look at example 3 here, or got it 3. Here it's nice and neat lined up for us. So we would just add straight down. The 8y is positive, and here it's negative, so we can just add straight down. That is a terrible straight line. Add straight down, and we have 3x equals 12, so x equals 4. We plug the 4 back into either equation, doesn't matter which. I'll just do 5 times 4 minus 8y equals 20. This is 20 minus 8y equals 20. We subtract 20 from both sides. We get negative 8y equals 0. Negative 8y equals 0, so y equals 0. So the answer here is just 4, 0. That's where they intersect. Okay? If I lost you anywhere there, make note of it, and we will go over that one in class. Equivalent systems. If we had two equations that come up to the same solution, all right, let's word this differently. When you multiply each side of one or both equations in a system by the same non-zero number, the new system and the original system have the same solutions. So the two systems are called equivalent systems. You can use this method to make additive inverses. All this means is that we can change the way these look so that we can then eliminate. So on this problem, I want to use elimination, but I don't have any terms that are opposites. Okay? So here on this top one, we multiply everything by 3, and we get 6x plus 21 equals 12. We multiply the bottom one by negative 2, and now we have negative 6x minus 10y equals 10, and now I have the opposite things. We can change the way the equation looks just by doing the same thing to both sides, okay? It's just simple algebra rules there for that, okay? So let's take a look at how this works. On this equation right here, or this system of equations, we have 3x plus 7y equals 15 and 5x plus 2y equals negative 4. So what do we want to solve for, okay? They're not set up for elimination. These aren't the same, and they're not opposite. So what could we multiply the top equation by, and what could we multiply the bottom equation by that would give us numbers that would add up to 0 so we can eliminate? So I'm going to multiply the top one by negative 5, and the bottom one by 3, and that's going to change the x's to negative 15 and 15. So we have, and you could have done the y's. It doesn't matter which one. So if you want to do that one, remind me in class, and we'll go over that one. So we have negative 15x minus 35y equals negative 75, and on the bottom we have 15x plus 6y equals negative 12. When we add those straight down, that's 0. This is negative 29y, and this is negative 87. Okay? And then y equals 3. From there, I just plug y into the original, so I can have 3x plus 7 times y is 21 equals 15. 3x equals negative 6, so x equals negative 2. So the answer here is negative there. X equals, so we have negative 2 and 3, and that is our answer. Okay. In problem 4, so that's example problem 4, we got y equals 2. Substitute that value into equation 2 instead of equation 1. Do you still get the same value for x? Hopefully you don't even have to do that to know. The answer is yes. If it's a solution to the system, then it's a solution to both. Okay, so you should still get the same equation. So that's the answer to that question. solving systems with unique solutions, okay? Some unique solutions. So solving system algebraically does not always provide a unique solution, without unique solutions. Sometimes you may get infinitely many, or you may get no. And here's how this works. If we were to, the solutions of these, if we were to add down, we would end up with 0 over here and 0 over here, okay? That is infinitely many. These are actually the same line. Those two equations represent the same exact line, okay? So just like if we graphed it and got the same line. So there's infinitely many solutions. Here, we add down, we use elimination, and we get 0 equals 16. Well, that's not true. This is an inconsistent system and has no solutions, okay? So, on the got it number 5, go ahead and take a second, try and get an answer for 5A and B. What are the solutions, and explain. Go ahead and pause the video now. All right, you've unpaused. Hopefully, for the first one, you got this is no solution, and that this is infinitely many. Okay, that's it for the notes. See you guys in class. Bye.